So, welcome to the new video. Today we will learn what is a continuous random variable. Okay, first we will think of how this comes up. If you have learned the discrete random variable, there are the numbers which fall in between the finite category or the numbers which fall between countable and finite, like. Suppose we think of the outcomes of rolling die. The outcomes will be 1, 2, 3, 4, 5, 6. Okay, this is the finite case. And suppose we think of a um, suppose a whole number. In the whole number, you have starting from 0, it can go up to infinity. But this 0 to infinity, you can calculate that. This is not very much big thing that you can calculate. But if you think of the numbers between 2 to 3, and you need to find the numbers, you need to find how many numbers fall in between 3 to 5. Sorry, 2 to 3. Okay, you can't even think of any. You can't imagine how many there will be. Think of, think it, think of it first. You will think there will be, you will say the number in between 2 and 3 is 2.5. Then you will move deeper and think of the number between 2 and 2.5. That will be 2.225, suppose. Then you will move deeper and think of 2.2222222222225. Okay, then you will finding the number in between that one. Then it goes deep and deep like a dig hole. You can dig it, and goes and goes and goes and goes. It can goes up to infinity. It is then here it is the case of uncountably infinite. Here I mentioned that one. It is a case of uncountably infinite. Okay, you can see the uncountably infinite case is the numbers between 2 and 3. So in this case, we are in need of continuous random variable. So I am taking another real life example. You will better understand about this continuous random variable. Suppose think of a car is moving and we said it was moving from point A to B with a constant speed of 80 kilometers per hour. Okay, you said this one. It was moving at 80 kilometers per hour. But if you really think that car is moving at 80 kilometers per hour, is it possible in a real life condition? We are saying it for a formal condition, but we are mathematics students, so we will first examine, then we will trust the thing, the statement. So if we placed a monitor in the car and check up for that whether the speed is maintaining at 80 kilometers per hour, so we can get the result that it was fluctuating like um, means there is no major fluctuation. Suppose it we can say it is moving at 80 kilometers per hour, but there are some minor fluctuation like this. Okay, there is some minor fluctuation in that monitor because we can't maintain a constant speed of 80 kilometers per hour. Suppose this line says 80 kilometers and we are going to 79.5 or 78.999. Okay, and it can go up to suppose there are very minor 79 point. Suppose this line 79.99999. Okay, minor, very minor difference from 80. In this case, you didn't know the actual speed of the car. So, if you, in this case, you integrate all the points on here and calculate the speed of the car, that will be more accurate for calculating that. Okay, so we will integrate all the speeds, all the f of suppose fx. Okay, the speed of the car is represented by fx, and we will calculate all the fx um, and integrate it with respect to dx, and it will be suppose from we will calculate from 79 to 81. We increase the range, and we we create a range. um, we don't say 80 kilometer per hour, we will say it was moving in between 879 and 81 kilometers. It will be more perfect and more accurate because the car cannot maintain a speed of 80 kilometers per hour speed throughout the distance from A to B. So, uh, if you integrate that one, you will get the speed of the means all the speeds that it has fluctuated and maintained throughout the travel. Okay, because that the speed depends on many things, whether um, whether humps or whether uh, uh, another car comes in front of that, another bike or another um, suppose motovlogger come in front of that one. You can think of that in the real life. Okay. So moving on to the statement, I told you two examples of continuous random variable where it is used. Why we are using that one? You will have a great deep sense of the continuous random variable now. So continuous random variable. Suppose there is a random variable. You know what is a random variable? Have learned it somewhere. We will discuss it in the later on video. First we are clearing this one. So a random variable x is called continuous if there is a non-negative function f of x such that it is in the form this one. Suppose we are thinking of a number line that is represented by x, a number in that line, okay, and the subset of that real number line is b. So we will integrate it from a to b. That point is b, so we represented it as b. That part it will be more clear when I will describe it in a figurative way. So you will stay calm. You will get everything after completing this video. Okay, you will learn everything. Don't be blank. Okay, so uh, it is represented by this way. It is derived to this way. Okay, first check this. First check this one. Okay, in this you can see we are integrating from a to b. That is f of x. Yes. You will learn about f of x and x. Okay, so I have taken that example from 2 to 3. Here you can apply that same example here. We have taken a number from 2 to 3. Integration from 2 to 3 f of x is. This is an the function the function f of x is called probability density function. Okay. And you must remember the definition, that is, the random variable f of x is said to be continuous if and only if um, and there is a non-negative function f of x. You will think of what is a non-negative function. Um, you can refer from the name itself, that is non-negative means it can't be zero. It will must be uh, zero or greater than zero. So f of x, f of x must be greater than or equal to zero. So if there is a non-negative function f of x, and if we integrate it from whatever, integrate it from the position a to b with respect to dx, then we will get the probability of x. Okay, this f of x, x is the probability density function. Okay, the first property for this PDF is, must write in your note, that is, it must be non-negative function f of x, and this is property 1. Second property is, it must be the normalization, must be using the normalization property. Okay, so what are they? So the first one you were clear, that is a non-negative function, that is f of x must be greater than 0. This ensures that when you calculate the probabilities which are area under the curve, you never get a negative probability, which is impossible. So area must not be a negative term. You are finding the area under that curve. Okay. We will now see in a graphical manner also to make you more understand. So another thing is, you were earlier defined that a definite one is we are finding for a definite, but a continuous is for an interval. So now we will see in graphical manner what this thing wants to come. Okay, so if you think of a circle, and the circle is the sample space, suppose the circle is the sample space, sorry, sample space, and this one is the event, and you draw this event in the form of graphical representation is like this, and you draw this line. You need to find the area between this curve. Okay, need to find the area between this curve. Suppose this point is A, this point is B, then the area under the curve will be, integration of A to B of f of x dx. This must be non-negative one, non-negative one, and the area you find, if you more think about it, why this must be non-negative, is the area under the curve or the area thing must not be negative. Okay, now you are clear, I think. So you must remember the 2 points, now three, because the first one is uh, when you will use this formula. Okay, so the first point is the function must be non-negative, non-negative function. Second one is you must integrate it from f of x. Okay. Third point is you must know from which point to which point you will integrate. Point to be integrated. Okay, these are 3 points. Must remember this one. So if you think of the speed of the car, it can be we can take 79 to 81, or suppose you think of you are in a suppose we were in an insurance company and you want to check. You must remember this example. That will be your best example from the lifetime. So if you think of insurance company is there and you are claiming the insurance, so they are actually uh, take off some measures and check off. They will not directly give you the payment back because there are some conditions are there. So they will first check up your speed, whether you are not moving. The speed will of the car is must not be greater than the speed limit of the road, and the person must be not drink and drive, and the person must be not engaged in mobile or in phone call during the drive. They will all check these conditions whether this all are maintained or not. After that, after checking that one, they will be giving you the insurance claim. So they will uh, check the speed of the car like this. They will find the probability and the probability that whether that is moving under the speed of 30 to 40 kilometers, and they will calculate that one. The formula I said just now, the f of x, and check whether this probability, how much this probability. If this is very less, they will move. Uh, they are not knowing the, uh, they are assuming the speed of the car. If they will check this with the conditions, these conditions will be given to them. Okay, this f of x, how they will calculate. They will just put the integration and the point uh, from where to where it will integrate. If this probability is suppose very less, this is 0.8, suppose 0.08, okay, this is very less, then 1, okay, they will calculate then 40 to 50. They will again put that value in the functions and check, and this probability comes as 0.5. uh, no, this probability came as suppose 0.1. Okay, they will further check the speed limit. They will increase the speed limit by suppose 60 to 80, and they get the value of the probability after calculating this one. They got the value 0.5. This is very huge. They will calculate one more and will sure about the thing. So now they will calculate a number greater than 100, whether the car is moving greater than 100 km per hour, and they will take up to 110. It came 0. Suppose 0.9 came here. Okay, 0.9 is means the car is actually moving. Means from you can from this even convey that the car is moving at this speed. The car is moving at 100 to 110 kilometer per hour. The probability of moving that in that speed is the highest. Now you will know that the car is overspeeded. You will tell your manager that they cannot claim the insurance as this is the defaulty of the driver. They are unable to claim the insurance. This is the use case of the probability in real life. You will be very much excited for this. Is there are real life things, the things you have studied till now are useless. Means the mathematics you are studying from the beginning up to 10th, there are no use case of the real life. You can think about it. But the probability we are studying now will be used in um, real life. We will claiming the insurance also. In the AI ML also you will be learning about probability. Okay, this is very exciting. The f of x will be given to you. You will calculate everything on the left side by putting the formula and get that value. So now we will moving further. Discuss about the second property, that is the normalization property. Okay. Now I can I think you are more clearer about these graphs things. Okay. I think that you can rewind the video and get more clearer vision of this one. These are very great concepts. Okay. So now we are moving to the next concept, that is the normalization thing. In the normalization, you are suppose you can uh, the property says integration from minus infinity to infinity f of x. The number line starts from minus infinity to infinity. We will check that whether this condition is true or not. Integrate from minus the PDF you will integrate from minus infinity to infinity, that is up to dx. This value must be 1. The normalization property says this must be 1. That is, the probability must be in between, oh sorry, this must be excluded up to infinity. Okay, this is a normalization property. This is taking up the whole. So in this video we have discussed about what is a condition, a continuous random variable, uh, how the continuous random variable we can say that is uncountably infinite thing, and the definition of continuous random variable, that is if a function is non-negative then we will move forward to calculate the continuous random variable. It must be firstly non-negative, then we will calculate the thing, and this is the representation of the continuous random variable. And going further, we discussed two properties that a continuous random variable must maintain. That is, first one is already discussed, that is the non-negative one. Second one is normalization property, that is sum from if we integrate, that is the sum. If we integrate from minus infinity to infinity, that must give 1 as the value. Okay. Then you have seen that how the non-negative part actually works. So if you think of the sample space, then there is a event here, If we plot the graph here like this, then you will getting that A to B. Here that will be integration from A to B. You will integrate the area thing. So the area must not be in negative term. So you will be taking the first condition, that is f of x must be non-negative, so that the area must not be negative. Okay, this is the thing why you are taking the function must be non-negative. Then I have told you an example of insurance company how this was used in real life conditions. Then the normalization property, that is the sum. This is the whole thing, as we will read one types of the random variable in continuous. You will learn more about what is that f of x, the PDA, and all that. Thank you for